Hello friends, welcome back to my channel Maths by Samit Deshmukh. So in this video we are solving question number 8 of Miscellaneous Exercise 2A of Matrices. So if you are new on my channel, subscribe the channel and hit the bell icon to get the notification of every newly uploaded video. See, in this example, we have to find out inverse of this matrix using row transformation, and in the second part using column transformation. So first we are finding inverse of this matrix using row transformation. So if you observe, the element of this matrix are in terms of trigonometric function. And which trigonometric functions are the element? Sin theta and cos theta, isn't it? So in such example, we have to make the use of this identity that sin square theta plus cos square theta will be equals to 1. Sin square theta plus cos square theta is equals to 1. In case if the elements are in the form of sec and tan, at that time we have to use the identity sec square theta minus tan square theta is equal to 1. And if the elements are in terms of cosec and cot, at that time we have to use the identity that cosec square theta minus cot square theta is equal to 1. So here three possibilities are there. Maybe possible that the elements are in terms of sin and cos, or elements are in terms of sec and tan, or the elements are in terms of cosec and cot. So let us try to solve this example using this identity. So we are using here row transformation. In case of row transformation, we are using which condition? That A into A inverse is equals to identity matrix. So write down the element of matrix A, where its elements are cos theta minus sin theta 0, then sin theta, cos theta 0, 0, 0, 1. A inverse, keep it as it is. On this side, write down the element of identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, in case of row transformation, what is our aim? Our aim is to convert this matrix into identity. Identity, let us revise once again the steps. Element of identity are 1, 0, 0, 0, 1, 0, 0, 0, 1. In case of row transformation, this is our first step. Means convert the element of first column into 1, 0, 0. So here we will require 1, isn't it? And if you observe the elements are in terms of what? Trigonometric function. So that's why we are trying to arrange cos square theta plus sin square theta here, so that cos square theta plus sin square theta can be replaced by what? 1. So here we will require what? Cos square. Here if we will require cos square means we have to multiply to R1. As is stand in R1, cos is there. If we are multiplying to R1 by cos, means what we will get here? Cos theta into cos theta will become cos square theta. Means we will get cos square theta. Again what we will require? Plus sin square theta. Plus means what? Addition. Whenever we are taking addition or subtraction, at that time we have to use the corresponding element of another row. So here our operation is on R1, so we are using here corresponding element of R2. And if I am multiplying to R2, what is the element of R2? Sin theta. But what will require? Sin square. So that's why I am multiplying to R2 by sin theta. So what will get? Sin theta into R2. R2 means what? Sin theta. So sin theta into sin theta will become sin square theta, and we have to take their addition. Now let us perform this operation very carefully on R1. Our operation is on what? R1. So observe here, these are the element of R1 and these are the element of R2. Our operation is on R1, but we are using corresponding element of R2. So here replace R1 by cos. So cos into cos will become what? Cos square theta. Plus, now replace this R2. R2, what is the value of R2? Sin. Sin into sin will become sin square theta. Now observe here what we will get. So R1 is minus sin and R2 is what? Cos here. So replace this R1 by minus sin. Minus sin into cos is minus sin theta into cos theta. Plus keep it as it is R2. R2 means what? Cos theta. So if I am replacing R2 by cos theta, here cos theta into sin theta will be equal to sin theta cos theta. Lastly, substitute R1 is also 0 and R2 is also 0. Both the term will become 0 and 0 plus 0 will become 0. In this way, we have performed this operation on R1. Perform the same operation on R1 on this side also. isn't it? So here R1 is 1 and R2 is what? 0. Again observe, R1 is 1 and R2 is 0. So replace R1 by 1, 1 into cos is cos, and R2 by 0, 0 into sin is 0. So here we are getting only cos theta. So cos theta. Now replace R1 by 0 and R2 by 1. R1 by 0 means this term will become 0. I am replacing R2 by 1. 1 into sin theta will be equal to sin theta. So here we will get sin theta. Lastly, substitute R1 and R2 equal to 0. R1 is 0 and R2 is 0 means both the term will become 0, and addition of both the term 0 plus 0 will be equal to 0. Keep remaining element 0, 1, 0, 0, 0, 0, 1 as it is. Okay, in this way we have performed the operation on R1. Keep element of R2 as it is. Element of R2 are sin theta, cos theta, 0, 1, 0, 0. Now once this operation is performed, then second step is to simplify it. So let us simplify this expression. So means wherever it is possible, simplify it. So here cos square theta plus sin square theta will be equal to 1. Here both the terms will get cancelled. Minus sin theta cos theta and plus sin theta cos theta will get cancelled. So here we'll get 0. Then here keep 0 as it is. So keep remaining element as it is. Sin theta, cos theta, 0, 0, 0, 1 into A inverse. On this side, keep all the element as it is. Cos theta, sin theta, 0, 0, 1, 0, 0, 0, 1. Now, here our first step. What is first step? The element of column first should be 1, 0, 0. We have got here. What will be our second required element? 0. So here we will require 0. As is stand, here we will require 0, but this is the element of R2, means our operation should be on R2. So what is the element of R2? Sin theta. To convert it into 0 from sin theta, we have to subtract sin theta, and our operation is on R2 means we have to use the corresponding element of any other row. So let us make the use of corresponding element of R1. तो sin theta में से sin theta ही subtract करना है, तो हमें यहाँ पे sin theta मिलना चाहिए, तो 1 को हमें किससे multiply करना पड़ेगा? Sin theta. So 1 into sin theta is sin theta, and sin theta minus sin theta means we have to take the subtraction so that this element will become 0. So let us perform this operation very carefully on R2. So our operation is on R2, so keep element of R1 as it is. Okay, so here R2 means what? Sin. Replace R2 by sin and R1 by 1. So here sin minus sin will become 0. Now replace R2 by cos. R2 is cos and R1 is 0. So 0 into minus sin is 0, and here R2 is cos. Cos minus 0 will be equal to cos theta. And both R1 and R2 are 0. So both the terms will become 0. So their difference is 0. So 0, 0, 1, keep it as it is. In this way we have performed the operation on R2. Perform the operation on R2 very carefully on this side. So there is no operation on R1, so keep the element of R1 as it is. Okay, so cos theta, sin theta and 0 are the element. So now here replace R2 by 0. So R2 is 0 means first term will become 0. R1 is cos. So minus sin into cos will be minus sin theta cos theta. Now here R2 is 1. And R1 is what? Sin theta. So here if R1 is sin into sin is sin square, and R2 is what? 1. So 1 minus sin square. So here we'll get 1 minus sin square theta. Now both R1 and R2 are 0. So both the terms will become 0. So 0, 0, 1, keep it as it is. In case if the elements of the matrices are trigonometric function, at that time after performing any operation, next step will be the simplification part. Remember it. So here first let us simplify it. So here 1, 0, 0, 0 cos theta, 0, 0, 0, 1, keep it as it is. So A inverse also as it is. Let us simplify it. So in the first row nothing is there to simplify. So keep cos theta, sin theta, 0 as it is. Okay, and here minus sin theta into cos theta as it is. 1 minus sin square theta is equal to cos square theta. 0, keep it as it is. 0, 0, 1 also as it is. Now lastly, if we are able to convert this element into 1, so this matrix will become identity matrix. So this is the element of what? Second row. So we are dividing to second row by what? Cos theta. Let us see what we'll get. 0 divided by cos is 0, cos upon cos is 1, and 0 upon cos is 0, means this element will become 1 if we are dividing to element of R2 by cos theta. So let us perform this operation on element of R2. So keep element of R1 as it is, 1, 0, 0. So after dividing to R2 by cos, can I say that here we will get 0, 1, 0, and keep the element of R3 as it is, means in this way we have converted this matrix into identity matrix. Perform the same operation on this side. Keep element of R1 as it is, cos theta, sin theta, 0. Now we are dividing to the element of R2 by cos. So divided by cos, cos will get cancelled. Here we will get sin theta. Again, if I am dividing here by cos, one term of cos from this cos square will get cancelled, cos theta, and 0 divided by cos will be 0. Keep element of third row as it is. So in this way, on this side, what we will get? A inverse into identity, it's A inverse, and the new matrices on the right hand side is nothing but our required value, means inverse of the given matrix. So using the row transformation, we have seen how to find out inverse of a matrix, and this is our required A inverse. Now same example we are solving applying by what? Column transformation. Now let us try to find out inverse of this matrix by column transformation, which is nothing but the second part of this example. So we have considered the given matrix. In case of column transformation, which condition we are applying? A inverse into A is equals to identity matrix. That A inverse should be prefactor here. So keep this A inverse as it is. We have substituted the value of matrix A, and on this side substitute the value of identity matrix. Now to find out A inverse, we have to convert this matrix into what? Identity matrix, where these are the element of identity matrix, means we have to convert this matrix into such type of identity. But whenever we are applying column transformation, our first step is to convert the element of first row into what? 1, 0, 0, means here we will require 1. So here we will require 1. So we are able to get 1 using which identity? Cos square theta plus sin square theta is equal to 1. This method we have already applied in case of row transformation. So same method we are applying here. Keep this A inverse as it is. Now our operation is on what? C1. So here we will require cos square theta plus sin square theta. So our operation is on C1. As it stands, what is the element of C1? Cos theta. But what we will require? Cos square. So we are multiplying to C1 by what? Cos theta. Isn't it? Whenever we are performing operation on any row, and if we are taking addition or subtraction, at that time we have to use corresponding element of any other column. So as it stands here, operation is on C1. So use the element, corresponding element of C2. So what is the second required term? Plus sin square theta. So as it stands in C2, minus sin theta is there. If I am multiplying to minus sin theta by minus sin theta, so minus sin into minus sin will become what? Minus sin square theta, because the element of C2 is minus sin. Minus sin into minus sin will become what? Plus sin square theta. So can I say that according to this operation, this element will become cos square theta plus sin square theta, isn't it? Especially this operation we have performed to get here cos square theta plus sin square theta. But observe here what we are getting. Observe it very carefully. We are replacing C1 by sin. So here we will get, if I am substituting C1 is equal to sin, so sin into cos will become what? Sin theta into cos theta. Again, here I am replacing C2 by its value. This is C2, and here corresponding element in C2 is cos. Cos into minus sin will be minus sin theta cos theta. So then lastly, here C1 is also 0 and C2 is also 0. Both the term will become 0 and their difference is 0. So then keep the element of C2 as it is, because there is no operation on C2. Sin theta cos theta 0. Keep element of column also as it is 0, 0, 1. So on this side also perform this operation very carefully on what? C1. So here C1 means 1 and C2 means 0. So replace C1 by 1. 1 into cos is cos, C2 is 0, 0 into sin is 0. So means here we are getting cos theta. Now C1 is 0, C2 is 1. So C1 is 0 means this term will become 0, C2 is 1, 1 into minus sign will become minus sin theta. Lastly, both C1 and C2 are 0 means both the term will become 0. So here we will get 0. Keep remaining element 0, 1, 0, 0, 0, 1 as it is. Okay, so whenever we are performing any operation, so one step we have to take for simplification. So let us simplify it. So here A inverse, keep it as it is. A inverse as it is. So cos squared theta plus sin squared theta will be equal to 1. So these two terms will get cancelled. So here we will get 0. So 0, keep it as it is. Then minus sin theta cos theta 0, 0, 0, 1 as it is. So on this side keep that matrix as it is. What are the element? Cos theta minus sin theta 0, 0, 1, 0, 0, 0, 1 as it is, isn't it? Now here we will require 0 to complete our first step. Once here we will get 1, so next required element in the first row will be 0. So means here we will require 0. So this is the element of C2 because we are performing or we are finding inverse applying column transformation. So here our operation is on C2. What is the element of C2? Minus sin theta. And what we have to add in minus sin theta to convert it into 0? Definitely we have to add plus sin theta. तो यहाँ पे हम C1 का करस्पॉन्डिंग एलिमेंट यूज करेंगे और C1 को sin थीटा से अगर हम मल्टीप्लाई करते हैं तो sin थीटा into 1 will be sin theta and sin theta minus theta will become 0. So means we have to take here addition because here minus sin theta is there and here we will get plus sin theta. So minus sin theta plus sin theta will become 0. So let us perform this operation on the element of C2. So keep element of C1 as it is. So here C2 means minus sin theta and C1 means 1. So what we'll get here? 0. Again C2 means cos and C1 means 0. Again observe this is C2 and this is C1. Here C2 means cos and C1 means 0. Means what we are getting here? Cos theta. Keep 0, 0, 0, 1 as it is. Okay. So on this side also perform this operation very carefully. Operation is on C2. So keep element of C1 as it is. Cos theta minus sin theta and 0 as it is. Now C2 means 0, C2 means 0 and C1 means cos. So here this term will become 0 and cos into sin will become sin theta cos theta. Sin theta cos theta, isn't it? Again observe here C2 means 1, C2 means 1, here we have got 1 and C1 means what here? Minus sin into sin will be minus sin square means 1 minus sin square theta. Lastly here both are 0, C1 C2 are 0 means here we will get 0. So 0, 0, 1 keep it as it is. Okay. So now we are simplifying it. Whenever any operation is performed, we have to simplify. One step we have to take for simplification part. So here 1, 0, 0, 0 cos theta 0. Here 0 is there. Sorry, here 0 is there. 0, 0, 1 is equals to. On this side also let us simplify it. So cos theta minus sin theta 0 sin theta into cos theta, keep it as it is, 1 minus sin square theta is cos square theta, 0, 0, 0, 1. Now lastly, to convert this matrix into identity matrix, only the remaining part is to convert this element into 1 and this is the element of what? C2 here, and we are dividing to C2 by cos theta. Let us see what we will get if we are dividing to C2 by cos theta. So here A inverse, keep it as it is. So can I say that here we will get 1 and this matrix will become identity matrix? Yes, if we are dividing by cos, so this matrix will become what? Identity matrix. Perform the same operation on C2 on this side very carefully. So keep the element of C1 as it is, cos theta minus sin theta 0 as it is. Just simply we are dividing to C2 by cos theta. So divided by cos theta, here cos will get cancelled, remaining term is sin theta. Cos square upon cos will be equal to cos theta, 0 upon cos will be 0. In this way we have performed this operation on the element of C2. So keep the element of C3 as it is 0, 0, 1. Now on this side, identity into A inverse will be equal to A inverse, and the matrix on the right hand side whose elements are cos theta, sin theta, 0, minus sin theta, cos theta, 0, 0, 0, 1 is our required inverse of the given matrix, and in this way we are finding inverse of this matrix applying column transformation. In this way we have completed question number 8. Inverse of this matrix we have got applying row transformation also and column transformation also. If you think that these videos are very helpful to you, so please like the video and subscribe and share these videos with your friends also. Thank you.